In this video here, we are going to look at some complex numbers, and we're going to focus on writing our complex numbers in what's called trigonometric form. Let's first look at what the complex number is. Remember, the complex number is a number that is in the form of a plus bi. If you remember graphing complex numbers, we graph them. We graph them like this. This is your a-axis, and this is your b-axis. So like the point 2 plus 3i is located here, over 2 and up 3. All right. Now what we're going to find is what's called the absolute value of a complex number. And the absolute value of the complex number looks like this right here with absolute value symbols. What it is that it is the distance from the point to the origin. Well, as we know, the distance from a point here to the origin, we can use the Pythagorean theorem. So this is a squared plus b squared equals c squared, and then you take the square root. So really, our absolute value of a complex number is simply the formula, the root of a squared plus b squared. You can see how it has a direct tie to magnitude. Same concept. All right, we're going to plot this point and find its absolute value. So plotting the point, so you go -2 and then up 5. Here it is. So then the absolute value of -2 plus 5i would equal the square root of -2 squared plus 5 squared. This equals the square root of 4 plus 25, which is equal to the square root of 29. All right, the next thing that we're going to look at is how to take and write a number in trigonometric form. Trigonometric form of a complex number. First of all, here are a couple things. You got your a value. Your a value is equal to r cosine theta, and r is the length of the distance between the origin and the point. And your b value is equal to r sine theta. Remember that cosine is your x value and sine is your y value. It's like xy. We're multiplying them by r. And in order for us to find the angle here, if we ever have to find the angle, you use the inverse tangent of b over a. And then you'll be able to find your theta. So here's what we know. We know that normally z, a complex number, equals a plus bi. My a is r cosine theta, so we have z equals r cosine of theta plus r sine theta I. So now we can conclude that our complex number is, let's factor out an r times cosine theta plus sine I, or we want to put the I in front, I sine theta. This is just a direction. Remember, this is just a direction vector. And multiplied by r, this is our trigonometric form of a complex number. That's how we will write it. Now I just want to mention how we got that a is equal to r cosine theta. What we know about any triangle is that cosine of an angle theta is defined as And let's go with this case right here. This is our radius. Cosine's defined as the a value over the r value. So of course, if I solve for a, you multiply the other side by r. This is where it comes from. So then I'm able to replace the a right here with r cosine theta, and I can do the same thing for the b value. All right, so here's the overall goal, is that we're going to be changing the form. So if you start in complex form, which this is considered to be standard form, then you substitute for a, for b, and we can substitute for theta, and that would put it into trigonometric form. All right, here we go. So we want to write this complex number in trigonometric form. So I'm going to go back to our steps. We need to replace a, b, and theta. Here's what we know. We know that z is equal to r cosine theta plus I sine theta. We need to figure out what the r value is. Let's do that first. So r is equal to the square root of -2 squared plus -2 roots of 3 squared. R equals the square root of, this is going to be 4 plus 2 times 2, so 4 times 3, 12. This is equal to the square root of 16, which is 4. So we know r is 4. Now we need to find our theta. Let's find theta. So theta would be the inverse tangent of b over a, and b is -2 roots of 3 over a, which is -2. So we're looking at inverse tangent of, the negatives cross out, the 2's cross out, inverse tangent of the root 3. And we also need to know that this gives us a result of a 60-degree angle. However, you have to look at what quadrant that we're in. So this trigonometric form, or this expression right here, is a complex number, and we are in the third quadrant because of the negative and the negative. We're in quadrant 3. So what angle has a 60-degree reference angle in quadrant 3? And we also would like to put it in radian measures. So z equals, our r is 4, cosine of, and we're looking for, again, 60-degree reference angle here. So that would be 4/3 pi plus I times sine of 4/3 pi. There's your trig form, right there. Right here is our final answer. So there's a couple things that I did. I had to find the r value, and I had to find the angle, and then you substitute it in. R and the angle. All right, now what we're going to do is we're going to look at writing a complex number in standard form. You'll see that in our next video, but for this video here, your assignment is page 430. (440), 1 through 31 odd.